And welcome back. We are in day 2 of biochemistry, and today we're going to be talking about the properties of water. There's some terms that you guys are going to need to know to understand the properties of water much better than you maybe previously did. Again, some of these terms may be familiar to you, others might be brand new. So water is a very unique substance in chemistry due to some of the properties that it entails. First one is cohesion. So cohesion is simply referring to the fact that water attracts other water molecules. So water sticks to water. We call this cohesion, water sticking to water. This explains the phenomenon of surface tension, which is really that film or that surface, the force on the surface of water that allows, examples here are water striders to seemingly walk on water, run on water. It allows water to bubble up. You've all done the penny experiment before where you see how many drops of water you can fit on the surface of the penny, and it tends to kind of bubble over and makes a little curve before it actually just falls off the side of the penny. That's what we're talking about. Those water molecules tend to want to stick to each other. You've also seen this on like a waxy surface of either wax paper or a waxed vehicle perhaps. So water sticking to water is going to be cohesion. Adhesion, similar idea, except for that in this case, water is sticking to some other type of surface. So cohesion is simply water sticking to water, allowing it to have that curve or that bubble up. Adhesion is water sticking to other surfaces. Examples here, if you've ever had your finger pricked, you're at the doctor's office and they need to take a small blood sample, they'll prick your finger, they'll put that capillary tubing right next to it, and the blood runs up it. Most of what is in your blood is water, so that water's running up that tube and kind of clinging on to the side or the edge of that either glass or plastic tubing. So water's sticking to the edges. Same thing if you put a straw, like a clear straw in a clear glass, you can see the water has that curve to it at the top of it, or in the straw. And you're supposed to remember the graduated cylinder example, you're supposed to read at the meniscus. Same idea. So there's that curve in the water because the sides of the water are clinging to the side of the material, whatever, if that's glass or plastic. So that's adhesion, when water sticks to other surfaces. Cohesion, water to water. Adhesion, water sticking to another surface. In these examples, either capillary tubing, glass or plastic. Polar simply means that in your water molecule, so here's your water molecule down here. We talked about this earlier. We have part of your water molecule that has a positive charge. The hydrogens have a positive charge. The oxygen has a negative charge. Those opposite charged poles or ends make water polar. And that polar quality allows water to be able to mix well with many other substances. It is by far your most common solvent, things that can be dissolved into it. And then simply opposite is nonpolar, does not dissolve in water because it does not have those oppositely charged poles. So polar meaning opposite charged poles and dissolves other substances very well. Hydrogen bond, we talked about this yesterday, also when we talked about covalent and ionic bonds. So hydrogen bonds are when you have two water molecules, for an example. Again, the hydrogen has a slightly positive charge. The oxygen has a slightly negative charge. The opposite charges attract, creating a bond between them. That bond is very strong in a solid. As that solid heats up and becomes a liquid, this bond becomes weakened. And then as it heats up even more, becoming a gas, that bond is completely broken. So this bond is what's responsible for the three states of matter, solid, liquid, and gas. Specific heat is another term you'll need to know, and I know for sure you guys cover this in 9th grade physical science, so this should be a recap for you. But specific heat is simply the amount of heat needed to change the temperature of a material by 1 degree. Metals change temperature very quickly, for example, so they have a low specific heat. They have a low amount of heat needed for their temperature to change. Their temperature changes quickly with just a small amount of heat. Versus water requires a lot of heat or a lot of energy to change their temperature. So they have a high specific heat. So 2 examples there. In this image here, you have a metal spoon and a wooden spoon in this like boiling pot of soup or whatever it is. That metal spoon is going to get hot a lot quicker because of that low specific heat versus that wooden spoon is going to absorb more of that heat and have a higher specific heat. It's going to take more energy for the wooden spoon to heat up than that metal spoon. We like the fact that water has a high specific heat because it helps to stabilize our Earth's temperature and climate. Most of our planet, surface of our planet is water. And the fact that it takes a lot of heat, a lot of energy to heat up and change the temperature of that water is a good thing because it helps to stabilize our climates. If water had a low specific heat and changed temperature dramatically, our climate and temperature would fluctuate much more dramatically and much more frequently. So if water kind of buffers our climate and temperature a little bit by having that high specific heat requirement. Some other examples of specific heat materials. Water, of course, we have on the top there is having a high specific heat, 4.18 joules per gram Celsius, and then lead, you'll notice the metals are on the bottom, right? So you've got your iron, copper, your lead, those things that heat up very quickly and don't require a whole lot of energy, so have a low specific heat, are going to be all those that, or many of those that fall in the metal category. So cohesion, adhesion, polar, nonpolar, hydrogen bonds, and specific heat are the main terms to understand today and how they relate to water. Amoeba Sisters does have a properties of water video. It's 6 minutes long. If you would like to view that, please click on this link.